Alright, welcome to another video, and in this video we will be looking at control flow. So what is control flow? Let's check it out. So control flow determines from the word control and flow. Control flow determines which block of code run and how often. It is the logic backbone of every program. So it's the transfer of execution. You can think of it that way. So what runs first, then what runs after, how does it go, how does it happen? So the flow of control, okay, the flow of power. Yeah, we can think of it that way. So under control flow, we have the conditional statements, which is where we'll be starting with, which is what we'll be starting with. And that's where we start looking at the common if, else, right? We start looking at if, else. What do we do? Now, conditional statements are codes that run from the word conditional if a condition is met. Okay, they are conditional statements. They are only meant to execute. They are only meant to do something if the condition specified for it is true. So let's look at the syntax first. The syntax is the most important thing. So the basic syntax, we have this. So I'll just copy all of them. So we can have if only. This is 1. So we can say example 1. Example 1, which is the basics. Basic 1. Example 1. We can also have example 2. Let's have example 2 right here. Example 2 is without the else. Without the Elif, I mean. So I'll take this guy out. Then example 3. Example 3 will be with multiple conditions. Okay. That will be example 3. So for the first example, we have a condition. If this condition results to true. You can see? Condition, literal true. If this condition results to true, we don't know what it is yet. But if it results to true, then this block of code runs. If it doesn't return to true, this just runs without any, let me call it out from here, without anything. It just runs without anything printed. Nothing gets printed out at all. Okay, nothing gets printed out at all, because it is only meant to execute if that condition is met. So we can do something like this and say syntax. All right, let me be sure it's not on the same level as this. Okay, good, it's not. So this is the syntax. And then we can look at what the examples under it. So we can say syntax, and then we'll have examples down here. Examples or practical examples, let's put it that way. Practical examples. Oops. All right, practical examples. Let's add some code cell down here. Just add a few because we'll need them. Okay, so let's go back to example 1. So if this is true, if the condition specified there is true, this whatever we put in here will run. If it's not true, the code will run without any error, but nothing will be printed out. Let's look at example 2. For example 2, if this condition is true, this code runs. However, if it is not true, that means, okay, fine, what if it's not true? Then this will print out, or this will execute. In this case, we don't have else. That's why this one will not return any output if the condition is not true. But in this case, if the condition is not true, this will run, and we'll see whatever we tell it to do. If you say, oh, then say it didn't run, or condition not met, or criteria not met, we can put whatever it is that we want in there. And for condition 3 allows for multiple options. You can consider this as ifs in Excel. No, consider this as ifs in Excel, where you have multiple conditions to check. So we can have as much as we can have a good number of Elif. So if we want another one, we can just copy, just do this, and then it keeps going all the way down like that. So we keep having and having and having and having and having all the way until all these conditions are not true. Then the last one runs. So for else, we don't add condition. If you notice, we don't add anything to else. We just say else, and we put whatever it is we want to put. Again, for the last condition, we don't put anything, right? Because it is if or when others did not run, when the criteria for others are not met, then this is meant to execute. Okay, so we want to keep that in mind. What is also important to keep in mind, and this will joggle our memory, about indentation. Now let's go back to indentation, which is the first thing we talked about in the basics of Python, right? When we're looking at the basic syntax and structure, we said Python is unlike other programming languages that uses curly brackets and semicolons. Python does not do that. So you can see that it was an if statement that we used in this case, right? So it's time to remember our indentation. So what are the key takeaways? What are the key takeaways from here? When you write an if block, after putting your condition, there must be a semicolon. Now, once you put a semicolon, remember we also mentioned and made emphasis on the fact that the IDs we use undo indentation for us. So you don't have to remember 10 spaces, 2 spaces, 4 spaces, right? So once you put semicolon, or full colon, once you put a full colon and you hit enter, it indents for you. The only thing is that you must keep that indentation level based on whatever it is you want to do, okay? So it indents for you. So once you put semicolon, so it is important that you do not forget your semicolon. Once you type if, you put in your condition, then you put your semicolon. If your condition, semicolon. Else as well, even though it doesn't take any condition, it still takes colon. The same thing for the rest. So that is very important to know. So use colon to start the block. Blocks are defined by indentation, 4 spaces, right? Elif is the same as else if. That means else if the one above does not execute, or if the criteria for the one above is not met, then run this. So elif in Python is known as elif, not else if. Other programming languages use else if. So let's jump into some practical examples and see how this really works. Okay, so let's say temperature. So temperature, let's say -5. So temperature -5, and we can say dress light. It can be boolean. Dress light, and we can say false. Okay, so here we can say if we'll keep this as variable declaration. So let's keep this cell as variable declaration and assignments. I'll just say variables, variable declarations, and assignments. Assign, okay, missing an N. Assignment. Yeah, that looks weird, but it's okay. I believe it's correct. So I'll execute this. Now, this is being underlined. Is it a keyword? Could it be a keyword? What could be the problem, right? How do we check? Do you remember how we check? So we import keyword, and we run that. And let's just do everything in that cell. So we can say is identifier. Do you remember? So we say is identifier. So we say keyword dot is identifier. Oh, we're not looking at identifier in this case, sorry. We want to check if this is a keyword. Identifier says, does it break the rule of what we want to do? So let's run it. So it says false. All right. So just in case, let's print keyword keyword list. So if we look at it all the way down, all the way down, all the way down, all the way down, we don't have what? We do not have any keyword. We do not have any such thing. So we can say temp, for example, in keyword. Then we'll run this and it says false. So that's one way to also check quickly, since we now know about the membership operator. So what could be the problem? Let's run it, and it is just misbehaving itself. So it's saying indented block. Is there an indentation before it? There is nothing. So let's just ignore it completely. Our collab is just having fun. I'll delete this particular one. Where is it? Delete this. Of course, it executed without any error, so we're good to go. So we want to say if temperature is less than 0. Okay, I think dress light in this case is not so useful for now. We'll put a colon, and now look at it. If temperature is less than 0, in fact, less than 0 is a lot. So if temperature is less than, let's say, 7 degrees. Now, on putting the semicolon, on putting the colon, the full colon, once I hit enter, you can see it's indented. It is not, it didn't go to the same level as the if. However, if I don't and I hit enter, it will go to the same level as the if. So that is how you know you missed something. So make sure you don't miss the semicolon, and you will have less struggle with indentation. Why? Because the IDEs we're using, whether you're using VS Code, because you can probably use VS Code for it as well, you can use Google Colab, you can use Anaconda, whatever it is you're using, it will handle indentation for you. So I'll say print dress heavy. Dress heavy. Let's just put something there like that. Dress heavy. So if we run this, we're getting what? Dress heavy. What if the temperature is 8? What do you think this will do? If we run it, it will not print anything. Okay, I didn't rerun this first. So now that I've executed it, now it says it doesn't print anything. It just runs. Why? Why did it just run? It ran because we do not have any, we didn't take care of the fact that if this condition results into false, what should it do? So we didn't tell Python what to do if this condition is false. That is why this just runs silently without any outputs. However, if we add our else block and we say print, okay, that's print dress light. So you can see now that this condition is not true, it's defaulted to the else part. Okay, it defaulted to the else part. Now we can combine condition. We can combine condition. So we can say, and let's use another one completely. Let's go into another cell and do something else. We'll declare a variable up here. And declare the variable to be score. So maths score, science score, English score 75, 92, 88. So we can say if we have to re-execute that so that it knows that those variables are available. So control enter. All right, executed. So we can say if let's say for example if the score, if math score is greater than 80 and science score is greater than 80, yeah, then you're getting an award. You're getting an award. Okay, so we can start with congratulations. That's a good congratulations. Congratulations, you're getting an award. So let's see what this runs or what this prints. It says, "Ooh, congratulations, you're getting an award." Why? Because this guy scored above 18 or so. What did we say? 90. That he has to score 90 to get an award. What do we get? We don't get anything because he didn't score up to 90 in the first one. He didn't score up to 90 in the first one. However, a cleaner way to write this, once you're having multiple conditions here, you can just pass in a bracket, which is simply parentheses. So you can have all your conditions wrapped in a bracket this way. And if you run it, it doesn't show any error. It still works just the way it should. If you change this to 85, and we run this, now it should print out congratulations, you're getting an award. Oh, getting, well, he has to triple get it. Did so well. Okay, so you're getting an award. And of course, we can use this to do a grading system, which will be part of your exercise if that is not already, okay, it's not already there. So exercise for you, create a grading system that allows students to enter their score and checks if their checks the range their score falls into, checks the range their score falls into, their range their score falls in, and then returns the grade based on the score. Returns the equivalent grade. Equiv grade. Okay, that's equivalent grade. So the system is 75 and above is A. That's A. Then 70 and above that is B. 60 and above, that is C. 50 and above, that is D. 40 and above, that is E. And below 40, that is F. So just create a grading system using this. So if can go and it can go on and do multiple conditions, and it's just nice. Okay, so we can check temperature. We can say if is a graduate and is employed, or if he has a laptop and is a graduate, if he's a graduate and is not working, if this, then you can say, oh, maybe enroll for a course, take a Python course, learn a skill, do all of those things as much as you can think of them. But I will not dwell on them much. You have a good hang of how to handle them. But let's just do one more example, and then we'll wrap it up. Yeah, okay. So we can say if, let's say, number, we decided to declare a variable up here. So we have not used the English score at all. Okay. If English score is divisible by 2. Okay. What we just did is if English score is divisible by 2. How is this if English score is divisible by 2? We're saying English divided by 2 is not equal to 0. Okay, that's equal to 0. So if English divided by 2, English modulus 2. So we're saying if the remainder of this division is equal to 0, then we say print is English score is an even number. Else is, okay, we'll do print is, okay, quotes, is English score is an odd number. Okay, is an odd number, something like that. So if we execute that, we say, oh, his English score is an odd number because 75 divided by 2 will have a remainder, and the remainder will not be equals to 0. Okay, so if it were equal to 0, it would have printed his English score is an even number. And yes, with this we wrap up the conditional statement. Okay, now we want to look at loops. From the word loops are something that run over and over and over again until on their own, right? Until a certain condition, a certain specified condition is met, or they are interrupted by, of course, condition as well, or a clause, a statement, which we'll all see. Loop, from the word loop, repeat. It's just like, let's say, for example, on Spotify, you have the loop option, right? Where you just add loop, the loop feature, which simply means to repeat this particular song over and over and over again. And in some app, you see it as repeat, right? You see it as repeat. Okay. So let's look at loop. Now we'll start with the for loop. We start with the for loop, and for the for loop is used when you know the number of times you want to iterate. Iterate means you want to loop over something. You know the number of times you want something to run. So when you know the number of times you want something to run, you use the for loop. Okay? And let's see an example so that it can make more sense to us. Now, what does the syntax look like? Let's start with the syntax. It says for let's say I in, we use the membership operator. That means as long as this is true. So we can say for I in list. So I can just put list, or we'll do high list instead. For I in I list, then we can say, we put a colon, then we'll say execute this. Execute this. So for I in a certain list, execute this. Of course, it's not defined. We know it is not defined. We're not running that code yet. So for I in this list, we want it to execute this. So the number of times until this condition becomes false, that is when the execution stops. Now, if the way for loop works is that as long as a particular condition is true, then the loop will keep running. That also means that if the condition never becomes false, or if the condition is always true, we will run into something we call an infinity loop. That means it just keeps running forever. Okay, and I'll simulate that for you to see. Okay, let's simulate that and see how that works. So let's say I have a fruit list, for example. Okay, this is just the syntax. We want the syntax here. Infinity loop trap. Infinity loop trap. So we'll create an armless list, fruits. And I prefer to create my list this way. Apple, mango, and banana. So it's easy that way. I'll just do the split it for me very fast. So we have this, and then I want to say for fruits in fruits, okay, print fruit, print fruit. Let's see what will happen if we run this code. Let's see if it will even run at all. Now, like we said, this particular one, we use for loop when we know the number of times we want something to run. So this time we run a valid code. Now let's see how we can run an invalid code. Why? Because here we're saying for fruit, as long as we still have something in this list, print them out. So when it gets to the end of the list, it stops. Okay, when it gets to the end of the list, it stops. So how can we do something that will cause us an infinity loop? That is what we want to see next, now that you understand the basic. Well, unlike the while loop, it is not so easy to fall into the trap of infinity loop in for loop. Okay, but regardless, we can simulate one. Okay, so here we can say fruits. We can increase the fruit list. So fruits dot append. Append just adds to a list. That's what it does. It adds something to the end of the list. So we can say um, grip. Okay, you can say grip. Now, when it gets here, it had this to the list, and this list never finishes. And you can see that it is already running. So it's not even printing anything. Okay, it's now printing, and then if you keep going, it keeps. You can see we keep going all the way down. See, if you look at this place, this thing jumps up, then we can go inside it, and it will keep running till eternity like that. Okay, you can see I'm trying to go back up. I'm trying to go back up now, but it seems to have gone so far. Let's run all the way up, and we can't even see it. So let me bring this up. Let's hope we'll get there at some point. Okay, so what can we do? Lesson learned. So we can do this, go to runtime and interrupt execution. Okay. So saving, our execution failed to interrupt. So we will do what? Restart all sessions. All right. So restart all sessions, and it's restarting completely. If we had not restarted, it will keep running until the browser can no longer take it, and then it crashes, just forced to close, and then we'll have to reopen it again. But in this case, we're trying to find a way to force close it. So if you scroll, you can see that a lot of damage has been done. A lot of damage has been done, and it says, oh, okay, keyboard interrupt, that we interrupted it at some point. If not, we'll keep going all the way. See what it has done. See what it has done. I'm still going up. I'm still going up. I'm still going up. I'm still going up. Still going. So feel free. Do not be scared. Feel free to try this. It's still going. So just use this instead to go up faster. All right. Okay. Let me take this up again. Okay. So now clear the outputs. Clear selected output. All right. So avoid the trap of infinity loop. Okay, avoid the trap of infinity loop, because in this case, every time the loop runs, that means whenever it gets here, it adds grep to that list. So once it adds grep to that list, it runs again. When it gets here, it adds another grep. So it keeps adding grapes. So that means it keeps going on and going on till forever. All right. So that's just an infinity loop to avoid. But you understand it better when we look at while loop. Okay. So how can we use a range? What is a range? A range itself, returns an object that produces a sequence of integer from start inclusive to stop exclusive by step. Okay. So what does that mean? That means if I do, now, one thing you should know is the start. Now, basically, you must provide a stop. So start is optional, step is also optional. So if I do 0, if I do 10, and we run this, this will not give, this will just show a range. So, but if we convert it to a list, no, try to convert it to a list. Of course, by now you should be comfortable with typecasting, because that's how we convert from one particular variable to another, one particular data type to another. So it also works for list and the rest. So you can see this is what we get underneath. Okay. Now that you understand that, we can say number lists. I hope we don't have number lists before. I think we have one. So let's overwrite whatever it is we have before. Okay, so we have number list now. And for this, we can say for I in range, or I in number list. To make it more descriptive, we can say for number in number list. For number in number list, what do you want to do? We want to print individual number. So that goes over the list. It checks the first number, prints it out, goes back to the top, check the second number, prints it out, goes back to the top, checks the third number, prints it, then keeps going until it gets to the end of the list. So you can see 0, 1, 2, 3, 4. And as we saw in the documentation string, stop is exclusive. Stop is exclusive. That means 10 is not included. So it stops at 9. So we can specify a starting point. Let's say 2, 7. So if we run this, we're saying start at 2, stop at 7. Of course, 7 is not inclusive. We can add a step and say step of 2. So just see 2, 4, 6. So that's what step does. Steps basically add the value we provided as step to the initial value. So if it started at 1, the next one will be 3, the next one will be 5, and all the way like that. If it started at 0, the next one will be 2, 4, 6, 8, all the way like that. So that is from a list. We can also do for states in, we can just have a state list directly here. And now we can decide to declare a variable called states up here, or regions. Regions, and then as usual, to make it easy, we just say south, north, east, west, central. Let's keep it at north, east, west. Okay. So we have south, north, east, west. Okay. We can say for region, so this should be plural, is just a good practice. Okay. This can be anything. We can say for X, but to make it make sense, we can say it's better to use what for regions. Do not forget your variable names, or the key or the names you use should be descriptive. So we say for region, in regions, print the individual region. So take every region in here and print them out. So if we run that, so let's comment this out. But if we comment this, it's going to throw an error. So I'll just say pass, for example, for now. So it will not disturb us for now. So you can see what we're getting. It's getting, south, S-O-U-T-H-Y, because we didn't remember to split. So it's seeing it as a string, not a list. So split it up, run that again, and now we're getting south, north, east, and west. However, this is not advisable. Let me not use the word advisable, but by good practice, if this variable is only meant to work for this loop, then it is not good to have it outside the loop, because after the loop stops working, the variable is not destroyed. And these are pro tips. These are pro tips that you should keep in mind. So one pro tip for you: if a variable is meant to be used for a single function, find a way to declare it within that block, such that if that execution stops, the variable gets destroyed. So how can we do that in this case? To do that, we just have to take this out, and then we can do this, or we can bring this way. See, we'll run this, we'll comment this out, I'll run this, and it just does exactly the same thing. Just to test that, so that I don't feel it's what we had before, let's use central, and you can see it does just that, and it does it perfectly. Okay, so this is another way to use for loops. And of course, we can use it. We'll also see how useful it is when we start looking at lists. It can do what we call comprehension for us. When we look at function, we can see how to use it for maybe lambda function, and how fast it works for us, which is also more of a comprehension. So for now, the most important thing you have is that you have an idea or basic knowledge, a good foundation on how for loop works. Okay, so that's the basic level. Now let's move up a bit. we want to do a little bit, we want to do something advanced. Okay, we want to do something advanced. And we'll go to enumerate. Now, what does enumerate do for us? We have a variable up here, fruit, which is still valid anyway. Fruit is still valid outside the loop, of course. So we can print fruit here just to be sure we're on track. Fruit. Oh, okay, it says fruit is not defined. So let me run that. Oh no. Aha. So I'll have to restart the session again. Runtime. Restart the session. Yes. So you can see the trap. I'll just comment this line out so that this does not happen again. I'll clear this L output. So let this restart and then we'll run the part again. Restarting. Clear. Still restarting. We'll wait for that to finish and then we'll continue. Okay, it's done now. So we can clear it. Let's select that output and run it again. So yeah, it's now printing properly. Now we can go back to use it. In this case, control. So we now have this 3, which is what we want. Now we can go ahead to do our enumerate. So we can say for, we can just say idx and fruit name in. Now we use the keyword enumerate fruits. So we can say print. Now we can make it well formatted. We can say, all right, the number idx, which is index in this case, the number 1 fruit is fruit name. So this prints, oh, the number 1 fruit is this, the number 2 fruit is this. So it will show A is the number 1 fruit, and we can make this better. Dot capitalize. Okay, so let's run this and see what we get. So you can see, okay, let's comment the fruit out at the top. So we don't want the lowercase that is in there. So we say the number 1, okay, this is number 0 fruit. So the number 0 fruit is apple, the number 1 fruit is mango, number 2 fruit is banana. And yes, oh, why do we have number 0? Well, if you're new to programming, welcome to the indexing in programming. Okay, now in programming, indexing or position starts at 0. So counting, or let me use the word position or indexing, starts at 0. So the first value will be 0, then the next one will be 1. Okay. Programmer's joke, by the way. If your bae or your boo tells you you are my number 1 and he's a programmer, all right, now you know if to trust him or not, because yeah, there's a priority 0. Yeah. Now the next thing, let's move on to zip, is if this is able to help us maybe split up, as it were. For example, in this case, we're able to like split up. What about we want to combine? What if we want to combine? So in this case, we can say student, want to create another list, student names. Let's add some space. Let's bring it up. So student names, we just use our list as usual. ADA, Jack, Bonnie, Finn, Duck. Okay, so split. All right, I think for once I should just write the list properly so that you're seeing it the way it should be. All right, but it's a lot of work though, and there's no accolade for writing it this way. So, but let's just do it this time. So this is what we use split to do. Okay, split does all of this for us behind the scene. Okay, which makes it easier for us. Let's write it properly this time. Okay, so this is what we have, and then the next one is a student score. Student scores. Let's just put it that way. So in this case, I'll just use the other way. So we can say 70, 95, 96, 73, 82. What am I using? Come out? 73, 82. What else? We have 1, 2, 3, 4, 5. This is, and we have 100. So we say split. Though this is meant to be a number list, by the way, but because we are using it as a string, so we'll not bother too much about that. Now, we want to now think of it. How do we print, oh, this so person scored this in a last exam. This so person scored this in a last exam. This so person scored this in a last exam. So we want to be able to print it individually. And of course, they must be of the same shape, of the same length. They must have the same number of items in them. Okay, they must have the same number of items in them. So let's jump into it. So we can say for the name, comma, score in zip. Okay, we want to zip it up. Then we'll pass in the student names, and student score. That should come up. All right. And this time we're using zip. We're saying print. So that's what the loop does for us. It iterates over it without stress. We don't have to manually do it one by one ourselves, and that's the power of loop. So we say f string, then we say name scored score in the last exam. That's all we want to do. So to show Ada scored 70 in the last exam, Jack scored 96 in the last exam, Bonnie scored 73 in the last exam, Finn scored 82 in the last exam, and Dark, which is actually Dark, scored 100 or 0. I mean 0 will be darker in the last exam. So let's run this and see what we get. Oh, boom. And just like that, we were able to use the zip function to combine these two variables together, all right, without any issue. And yes, we can go on and on and on and on with more examples, but when we get to some practical application part of it, then we can maybe see how it works. We can now think of it and apply them, in fact, in more complex situations. So for now, we are done with the for loop. And don't forget, for loop is used when you know the number of iterations, simply when you know the number of times you want a loop to run. Basically, that's just all it means. And that's why you rarely fall into the infinity loop trap using a for loop, right? You must have really written some bad code. But naturally, for a while loop, that can, well, naturally might not be the word, but yeah, it can easily happen in a while loop. So let's look at a while loop. Now, a while loop is used when the condition is dynamic or unknown ahead of time. For example, I don't know how long something has to happen. don't know how long something has to occur, something has to take place. But all I know is that once this thing is done, then stop my loop. In a for loop, we can tell, oh, for this list, how many items do we have in the list? 3 times. So this loop will run 3 times. But for a while loop, we can't ascertain that. What if we say, oh, now think of it as a game. Let's say we want to play a game. And we say, we tell the user to put in the number of times, the number of retries that they want. Now, the number of retries for individual players or individual player will be different. A player can put in 1 retry. Another player can put in 3 retries. Another player can put in 5 retries. Another player can put in 10 retries. So it is dynamic. You can tell, oh, this is the number of times this will happen. So what do? You use a while loop. So you say, while you have not exhausted that particular thing, while that condition is still true, then do this. Keep doing this. Keep letting them play. Keep letting them play. But once they exhaust the number of retries, then they cannot play the game anymore. So let's start with the syntax of while loop. So we say while. Let me just put a comment and say syntax. So I'll say while condition is true, execute this. So whatever condition we now put is something we must make sure must later become false, so that we don't see the infinity loop as earlier. So let's say, for example, let's use the idea of what we just said. Number of retries, number of retries. Okay, so we let them enter a number of retries. For now, we'll put it at 0. Okay, number of retries 0. And after that, we want to say while the number of retries is less than, so less than 5. Okay, why did that? How did 5 jump out there? Okay, so let's say what number of retries is greater than 0. Yeah, so as long as they still have certain number of retries, okay, then we want to say print guess a number. Of course, we'll develop this properly in, let's say, the next code cell or something. Guess the number. So let's say it's the game, guess the number. Now let's execute this. If we execute this, do you think it will run? Do you think it will not run? I'm not going to execute it. Let's just read through the code. So the ability to read the code and know how it will work or what it will do is very important. That means you understand what is going on. That means you don't just write the code, you now understand it. So let's look at what we have. We set the number of retries to be 0. And we're saying while number of retries is greater than 0. Is 0 greater than 0? No. It says print guess number. So we already know what this will be. However, if we put this to be 5 and we run this and we execute this code, it will run into an infinity loop. Why? Because 5 will always be greater than 0. So what must we do? We must find a way to make sure that we reduce this number every time the loop runs. So how do we do that? We will now say number of retries minus equal 1. You remember this assignment operator, so we can use it to reduce the number. So when it runs the first time, they have 4 number of tries left. So we can now print. Oh, we'll spice it up in the next one. So let's run this. And you can see guess the number, guess the number, guess the number, guess the number, guess the number 5 times, and then poof, they're out of retry. So it printed at number 5, which is the start, at number 4, 2, number 3, 3, number 2, 4, and number 1, 5. So let's make this into a full proper application with the knowledge of all we have had so far. So we'll say, put it here, number of retries will be from the user. And do not forget, I will intentionally simulate an error here. So enter the number of times to play. So we can first print welcome to the number guessing game. Number guessing game. All right. Full stop. Then we say number of retries will be equals to enter the number of time you want to play. Enter the number of time to play. Enter the number of retries. Enter the number of retries you want. Okay. So we can do \n. Let's see your guessing power. Let's see your guessing power. All right. So we have the number of retries. They put in the number of retries, and while the number of retries is still here, we'll get their input. We say guess. So we'll call the variable guess. And you can see now that it's getting more interesting. So we'll call the variable guess and we'll say input. Then we'll say guess the number. All right. So guess the number, and we'll put the space there. So we can now have an if statement that say, oh, if the number is correct, that means once they get the accurate number, they should we should tell them, oh, congratulations, you guessed right. Oh wow, so smart. Or different message, right? Different kind of message. So for now, let's just keep it simple and see what we have. So what will our function do? To print out this first, just once. This will only print once, and then ask them for the number of retries. And while the number of retries is greater than 0, we want them to guess the input until they can no longer guess an input. Okay. Of course, there's an issue with this code, which we're about to find out in a moment. So it says, oh, welcome to the number guessing game. Let's see your guessing power. So how many number of retries do you want? 5. You see? And it runs into an error. And our game crashes. Our application crashes. Why? It says str is not supported. By default, if you remember, user input is always a string, but we want to use it as a number. So what must we do? We must convert it int and int. So right here, we're now converting it. Okay. So let me take this out once, and then this should be at this point, \n. Okay. So this is what we want to have. So now we'll get an actual number, and if we run this again, I'll just put 1 there, 2. This time number of retries. Now let's see what happens. So I say 2. It lets me guess again 1, and then the game stops. But I don't know if I guessed it right or not. So what can I do? We have to have the secret number somewhere. So we can say secret. Is that how to spell secret? No. Okay, secret number. Then the secret number will be, let's say 7. Okay, then we can say guess the number, and we say if. Now we're combining the conditional statement with this. Now do not forget that this is a text as well. We have to convert it to a number because our secret number is a number. Let's take this out. So we'll say if guess equal secret number. That's the only time it will print, else it will not print anything. Print, yay, you guessed right. You guessed right. Of course, we can say, and at this point, we'll decrease the number of retries. So you can see how we are building up our, okay, we don't have secret, it is secret number. You can see how gradually we are building up our code. We're already thinking, we're applying, we're putting it together. So let's run it. It says, oh, welcome to the number guessing game. Let's see your guessing power. How many times do you want to try? I just want to try twice. I'll put 0. I'll put 9. Oops, I didn't get anything. I didn't get any result or anything. Let me try again. This time I want to guess once and I'll guess right. So I'll put 7. And yeah, you guessed right. Of course, I know the number. That's why I guessed right. So this can be something behind lottery and, you know, all of these games you're seeing and the rest. Okay. So you can see it says, oops, you guessed right. And yes, guessed right. So we have been able to achieve this with while loop. Now you can see that even when the number of retries changes, our application still works perfectly because while loop takes care of it. It takes care of it for us. Okay. We will now see how after we look at the control loop statement, we'll now see how we can make the game stop once they guess it right. How we can make the game stop when they guess it right. So for that, we'll leave while loop. Now we have seen the basic option of while loop. We have seen how while loop works. While a particular condition is true, do something, but you must find a way to what? Increment or decrement it. That is very important. Okay, so let's close while loop and let's look at loop control statements. Now, what are loop control statements? We have the break, which immediately exits the nearest enclosing loop. Because if it's inside a nested loop, it breaks out of the nearest one. Okay, it doesn't stop the entire loop, but the one that is closer. So where you place your loop, or where you place your statement, your keyword, excuse me, where you place your keyword or your statement is important. The indentation level, so that I can know, is it this one I want it to break out of, or it is this one, or it is this one. Okay, I know you're not saying this one that I'm talking about, but we'll see it practically. Continue. Continue skips the iteration and jumps directly to the next loop evaluation. Let's leave the English. What does it mean? Jump and pass. So if it's meant to print 3, it jumps over 3 and prints the next value. That's it. Pass acts as a syntactical structural placeholder for unwritten logic block. That means I don't know what I want to put in here yet. I think we use that somewhere right here. Oh, we used pass here. See it here. So we're saying I don't want you to print this guy, but I don't want to declare anything here for now. So that means my for loop does not want to do anything for now. So just pass it. It's just a placeholder that, okay, I don't know, I'll come back to it when I'm ready. So that's what this does. So this is more of a summary statement. Exit loop immediately, of course, the nearest one. Continue skips iteration. Pass does nothing. So let's see continue first. Then we'll now look at break. So for continue, I think we have something like continue right here. But let's do our own. So we can use the same example. So for number in range 1, 10. Say for example we want to print the odd numbers. Okay, so we'll say if number modulus 2 is not equal or is equal 0, what do we want to do? Continue. Okay, I want you to continue, then print a number. So you should check first if that number is an even number. Okay, we want it to jump and pass over it. So let's say print odd numbers only between 1 and 10. So let's run it. Let's see how it does. You can see 1, 3, 5, 7, 9. As simple as that. So we're saying whenever you divide, before you print, you can see where we put the print. We put the print. Now let's make this clear. See the indentation level, right? Continue is for this, but the print is directly for this. But this is a good check. Saying, hey, check before you print this, before it even gets to this print, check. So if you divide the number by 2 and the remainder is 0, that means it's an even number. Skip it. Don't print it. If we say not equal to, then this will print what? Even numbers. So, but once it's equal to, so it prints odd numbers only, right? What if I say, I can say if, I can use elif or else. I can say if, that means however, even though the loop is not meant to stop yet, if number equal 7, right? Break. And this is how to use break. We've already seen pass. So once it gets to 7, it will not even print it at all. It checks this first, then checks this again, then cuts the program off. It just stops it abruptly. Okay. So now let's look at that, and that's what we have here. So it says for number in range of 1 to 10, if number is 3, skip it. If number is 6, break it. That means stop it completely, terminate it. So let's run this and see what it says. It says active step 1, active step 2, skips active step 3, then it prints active step 4, active step 5, then it stops executing, right? Because normally it's supposed to print up to 9, but because we said break, it stopped printing. So let's wrap it up or cap it up with it's a code, our loop, our while loop that we have earlier. Let's make this better. The number guessing game. Control A, Control C. So we want to do that. Once they guess the answer right, we want to stop the game. We want to stop the game. So this is what we have. So we can say if secret number, yeah, you guessed right, and then we just put a what? A break. So regardless of the number of retries that they have, we just want to stop the game. So let's run it. So let's say I want to put 5 retries, and the first time I guess 2, it keeps coming. Second time I guess 4, third time I guess 7. It says, yeah, you guessed it right, and you see our program stopped immediately. All right, so before this milestone exercise, I have an upgrade version for you. So upgrade the number guessing game to do the following. That's 1. Of course, 1. Oh, that's hashtag. Let me just use this. All right. So 1 tells the user the number of retries they have left. 2, if okay, print oops. Okay, let me just, I don't have to put it the way it should look like. So print this. So we'll just say print oops, you are out of retries. Do you want to play again? Do you want to play again? Now, 3. If user enters Y or yes. If user enters Y or yes, let them play again after requesting the new number of retries. So the game should only stop on 2 conditions, right? So you can see you're going to have fun with this. Game should only stop on 2 conditions. One, the user guessed right. The user guessed right. 2, they are no longer interested in playing. They are no longer interested in playing. So for this, I think all the best. You're gonna have so much fun with this. Just take your time, do it step by step. Okay, break it down. Do not rush over it. Take it one after the other. Okay, take it one after the other. Of course, I can keep adding conditions to this, and then it just keeps going on. But yes, you can handle this. This is something you can handle yourself. So I'm waiting to see what you do. Do not forget to share your work, post it, post your notebook in the Telegram channel. You can share the link to your notebook directly, or you download the file, but sharing the notebook link is better, so you can view it. Other data enthusiasts and professionals can also see it and share their thoughts with you. So do well to follow the link in the description below to join the Telegram channel, where you can do that. You do not want to miss out on that. So I'll collapse this now. I've seen the control loop statement, and oh yeah, our mini exercise first. Mini exercise. So our milestone exercise, of course, there's an exercise for you to do right here. So okay, I think it's just 1. It looks like 2 to me. It should be 1 to 30. Let's make it 1 to 30. Now write a program using a for loop. This is a while loop, so this one is for a for loop that goes over the number 1 to 30. Now for each number, print data. If it is divisible by 3, you should print data. If it is divisible by 5, you should print science. If it is divisible by both 5 and 3, then you should print what? Data science. And if the number, that means, and the number itself, if it does not match any of this condition. So for example, you should have 1, 2, data, 3, science, data, again, which is 6, all the way like that. So all the best and have fun with these exercises. Do not forget to post your work in the Telegram channel below. The Telegram channel, use the link in the description below to join the Telegram group. Waiting to see what you will do. And I'll see you in the next video, where we'll jump into functions. It's going to be much more exciting. See you there.